what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Joining me every week is our brother Pedro. Hello, hello.
Good morning, everybody. I'm Pedro Ross, Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to the show. We are streaming live on all the usual networks. It's episode 531. And it is June 17th. It's Wednesday. It's 2026. If you'd like to join us throughout the show, you can hit us up on any of the usual places like Facebook, LinkedIn, YouTube, Twitch, and X. But also, we're hanging out in the Adafruit Discord server in the live broadcast chat channel. If you want a URL to get invited to join the Discord, it's discord.gg/Adafruit. You can find the link up here in that purple bar at the top right. We have a new Learn Guide. So we got a new project that just dropped earlier this week. So we'll talk about it, walk through the Learn Guide. We have, let's see, we'll go through some coupon codes and some freebies. We have a Timelapse Tuesday video that we'll talk about. We have a couple of community makes. And of course, what are we prototyping? We are making lots of progress on stuff. So let's go ahead and jump into adafruit.com/free. This week, 3 deals going on. If your order is $99 or more, you get a free PCB coaster with that golden Adafruit logo. If your order is $149 or more, you get that golden Adafruit logo plus the Adafruit KB2040. It's a lovely microcontroller featuring the RP2040 chip. And at the top tier at $199, you get the KB2040, the PCB coaster, and free UPS ground shipping for continuous US only. Adafruit.com/free. These get automatically added to your cart. And while you're at checkout, once you use our coupon code, good for the next 24 hours, it'll get you 10% off your order. The coupon code this day is PROPIT in celebration of this week's project. It's been cooking. It's been cooking for a little bit, and it's finally baked and ready for consumption. So yep, we're up on the Discord. So if anyone has any questions about it or about anything, we can chat about it. I'm really excited to jump right into it. So I've been talking about this device, 3D printed electronic toy game inspired by the 90s game Bop It. We called it Prop It because it is featuring the Adafruit Propmaker feather featuring the RP2040 chip. It's got all the bells and whistles you need for a prop that can do sounds. It can do accelerometers, detection. It's got connections up here for neopixels, buttons, switches, servos. In our case, a Hall effect sensor that's doing the spinning detection. So if you ever want to do like a little spinny thing and control maybe a neopixel or some audio, you can do that with a nice Hall effect sensor. Yeah, so this is a collab project. We collaborate with all sorts of folks on the Adafruit team. Liz Clark did the code. Dan Q did the sound effects. Bruce Yan did the awesome 90s graphics for it. And I, of course, did the ideation and the design. It's 3D printed. We have 2 versions. You can 3D print it in these 2 colors using an AMS or a multi-material printer, or you can print the single color version where you just add in the little light diffuser for the NeoPixel. For the display, we're using the alphanumeric, the 14 segment display, so it can do numbers and letters. We have a little mini over speaker here that connects to the built-in I2S amplifier on the feather. Feather's got a 2200 milliamp LiPo battery. It's those cylindrical hard shell batteries. So you can charge that battery via the USB-C port on the feather that's located down here on the device. On and off switch here. It's just a nice simple on and off switch to turn on and off. A couple screws that holds it together. And give me 1 second while I figure out my latency. Okay, there was a little delay lag on my overhead camera, but we're good now. So you flip it on, tells you to push start. You can change that text to say whatever you want. You can make it say someone's name. You can make it say happy birthday to somebody special. So it's all CircuitPython, really easy to edit. As it's looping through, like it's just waiting for you to press this button to start the game. The NeoPixel here is just doing a really slow pulse of changing the color. So it's using the color Rainbow, Rainbow IO, I believe, to do that, just to show some nice color there. So why don't we quickly play it? If you can hear it, great. If not, sorry, but it's using the audio module that's built into CircuitPython to do multi-channels. So you have multiple channels, and you can adjust the levels and speed of those channels, which is really nice. Let's go ahead and start the game. It does some nice little things, tells you what to do, and you have to hit the right thing before this timer runs out. So the NeoPixel stick, it's 8 NeoPixels, and it is being used as a timer. Every 5 turns, it gets a little bit faster. So there, the audio is using the audio speed to go faster, and it's just incrementally gonna go faster. I think we topped it out at when you reach 30 or so. So for Shake It, we're using the accelerometer, and I missed the timer and lost. So it says game over, and it gives you the score. It'll do that twice, so you can get at least 2 times to look at your score. And speaking of scores, my highest score is 120.
Oh, wow.
And then Liz's highest score was 304, which is bananas. Like, she was in total flow state when she was playing it. So you can definitely get over 100 points on it. Really cool enclosure design. I'm really happy with this one. No support materials for anything. Everything just kind of, you got a couple snap fit things, like this back cover snaps into this kind of hood thing. That's what kind of creates this fun looking display enclosure that's like kind of separate from the main enclosure. And then these screws are countersunk here to kind of sandwich the electronics together. These 3 components here are panel mounted. So you can pop this out if you want, unscrew these if you want to change that out. But yeah, it's the 35mm slider, potentiometer slider, and then just a regular toggle switch that has, I think, 3 legs on it. Let's see, the NeoPixels right here, speakers right there. That connects directly to the screw block terminal on the Feather, what we'll talk about. And then my favorite part is, of course, the hidden magnets here. I actually exposed the magnets here just so I can show that that's how it works. But you could, of course, add a little cover here, or like add another layer you could do one of those print things where you embed the magnets. You could do that if you didn't want to expose it, but it's all modular. So this piece here has this screw that holds in there and has some registration pegs so that this can't move. So it's nice and solid. And the ball bearing here is your standard skateboard ball bearing. I think it's the 608ZZ or ZZ608. It's your standard ball bearing. We stock these in the shop because they're really good ball bearings. Screw holds it in place there. Inside this little pink housing has the Hall effect sensor. A little bit weird to use the Hall effect sensor in terms of like you gotta solder a 10K resistor in between 2 legs, and then 3 wire connections scoot out and connect to the servo pins on the Propmaker Feather here. I actually did it on the bottom here just to kind of make the wiring a little bit cleaner, so it's not like all facing up. But we'll take a look at that in the guide. Something about this guy here. These are really fun and easy to work with. Not so great to use screws because the PCB has very minimum clearance for screw holes. So what I ended up doing is one of those snap fit little clips that you've seen us use in things like the Cutie Pie snap fit things. So it's kind of like a similar thing where it like kind of grabs into this bottom piece here. But the other thing is, you'll notice that, why is it black here? It's because it's just a gel filter. You can purchase a pack of gel filters and use scissors to cut it, which I did. And what you'll do is you'll cut that down to shape so that it fits behind this black faceplate, and the black faceplate just gets press fitted into this white frame for the display. So kind of a neat thing. If you're ever using these things, it's great to have a little gel filter to diffuse the LEDs, because it kind of gets washed out with just bare like that with these little displays. They can be a little bit hard to photograph too because of the flicker, but you guys saw it on the overhead. It seems to work pretty well.
No, it's absolutely required. Otherwise, you cannot.
Absolutely required. Thank you for that. Yeah, so that's cool. And if it's too loud and stuff, you can You can adjust the CircuitPython code with one value. You can change the 1 to a 0.5 if you want to make the volume. I think we set it to like 0.4 or 0.6. So it's not going to be like ear piercing, but you can make it really loud if you want. There is also I haven't really used this. I think you've used it before, but there is a little gain, an amplifier gain if you really want to pump out the audio. But you don't have to do that. I'm just saying that is an option. You can always pump up the jam. Yeah. So really fun to play with. It's addicting, so be careful. And let's go ahead and jump into the Learn Guide, and we'll kind of talk about it. So let's see the Learn Guide. Learn.adafruit.com is where you'll find the Learn Guide. It should also show up in the new. Yep, we have one from Tim C this week, Aaron St. Blaine, John Park. But yeah, check out the Propmaker game. There it is. Some nice photos. We got a video out there. The overview just describes all the features and stuff. Shout out to Bruce for putting this cool graphic together. It's really nice. We also have just a random demo here of it. But for all the parts, let's take a look. We got the Propmaker feather is in stock. Awesome. The alphanumeric display says it's out of stock, but here's the trick. If you want to get one in a different color, let's say you want it in white, well, it is in stock. We have blue, out of stock. Red is out of stock. Let's see, green. Green is in stock. That would be nice. So you have those two. I have the yellow one because I kind of like the yellow that contrasts as well with the color scheme. But you do have the option to either get the green one, the white one, or try buying it from DigiKey. It seems like DigiKey has them in stock. They just did a big purchase order from us, so that's great. But yeah, you do have to solder these guys together, so they come unsoldered, but it's easy to connect to the feather because you can see here in the photo, it connects via this demo QT cable. And I think you can see that they even put the filter here, maybe, right?
Perhaps.
I think they did. Yeah, good job.
Because it's super hard to read without.
Yeah, it is. It gets really washed out. But anyway, NeoPixel Stick is back in stock. That's great to see. These little guys are fun to play with. These little slide potentiometers. So they come with knobs, and this is the first time I 3D printed a knob replacement because I really wanted the input controls to have the same color scheme, which is cool. Chotkey switches, you might have some laying around, but we sell them in a pack of 5. I recommend the white ones because they have that nice clicky sound. Panel mount toggle switch is the single pole double throw toggle switch. That means it has 3 legs, and those are in stock. So we're looking pretty good in terms of all the things in stock. The Hall effect sensor is in stock. Great. It's a little guy. It looks like a little. What is that? That Circuit Playground character. That
I
looks
believe
like
that is Hans.
Hans the transistor.
No, it's Connie.
Like Connie the transistor. Yeah. So it kind of looks like a transistor. I cover how to solder it and all that here. Ball bearings. Let's see if those are in stock. Yes, you get a pack of 4. Those are in stock. So that's great. The batteries. Oops. I think those are in stock as well. If it says add to cart, I believe it is in stock. So that's good to see. So yeah, everything's in stock. The only thing that's not from Adafruit is these neodymium magnets. It's very specific size of neodymium magnets. If y'all can see this, they're 22 cents per one. So I would just get a bunch of them. You might use them in other projects, but here's the dimensions and all that. We like K and J Magnetics. They have a really big, they have a plethora of different neodymium magnet sizes, and I tend to go to them for my magnets. So that is, of course, what triggers the Hall effect sensor, which is used for spinning. So the spin detect is kind of done through that. And then, some extra bits and bobs. The light gel filters, I get them from Amazon. You can get a pack of them, or if you have them laying around, you can probably use those. 10K resistor. We do sell a pack of 25. You can get those, but you might have them on hand. And then, who doesn't love silicone stranded wires? I recommend getting every color because they really help with the wire connections to distinguish them all. So that's good. And then, of course, the stem QT cable. The 100 millimeter long was just the right length where it's not too short and not too long. The Goldilocks stem QT cable in this case. Before you build this, make sure you have all these screws. There's a little bit of a mix of M3s, M2.5s, and M2s. and that's because all the components require different sizes. But it's better to have them secured with the screws. The only thing that isn't secured, I guess, is the display, but it's pretty secure.
Sandwich. Yeah,
it's sandwiched perfectly and with friction fit. All right, let's take a look at the circuit diagram. Looks a little daunting, but I tried my best to arrange the parts how they actually are in the build. So this is like version 7 of it. So I did a lot of back and forth, making sure that it's pretty good. The only thing that isn't kind of correct is that the Holofix sensor is actually started to the bottom of this. So just as a FYI. But otherwise, you got a lot of connections that are going into the screw lock terminal, which is great. But yeah, everything is broken down here in text if you want to see everything. But yeah, you want to get a good idea of your wiring situation here. But don't worry about wire lengths because I'm going to cover them in the assembly. CAD parts, make sure it fits on your bed. The biggest part is like 100 by 135 by 31 on the Z. Not bad. And then you can download the 3MF files, which are oriented and ready to go. Or you can download the step file, the fusion file, and I think that's it for the source because that's plenty right there. So you can make your own remixes if you want, or reference things if you want. Otherwise, get the 3MF files, and you can choose whatever color to print. And in that 3MF zip file, you're going to find a multicolor front cover and a single color, and it's named appropriately, so there's no confusion there. That's pretty much it for 3D printing. Again, no support material. Everything's oriented as is. Yeah, it's all tested with PLA. If you can get your hands on a PLA kind of pro blend, I would go with that, just so that's like nice and like rigid. But I used whatever Polymakers, I think it's Polyterra, Polychroma, whatever they call it these days, is the filament that I used. Okay. Yeah. CircuitPython, this just shows you installing CircuitPython to the latest. I think mine is running CircuitPython 10X. So that's what's running on the Feather. The code, you'll want to hit that download project bundle because it's going to include those sound effects. So here's what it looks like. You get your code, a couple different libraries. You got the I2C bus device library, the library for the LED display backpack. The LIS3DH is the accelerometer. Pixel Buff is for the NeoPixel. Adafruit Tix is for doing the timing stuff. NeoPixel is the standard one, and Simple IO does the I think ranging and averaging of the potentiometer. You can use Simple IO to map those values easier. So that's why we're using that library. Shout out to Liz Clark. Everything is broken out here. So if you want to change any of the pins, any of the sound effects, any of the text, it's all in that dictionary here. Here's how we're mixing the audio stuff. So if you want to change the rate, the speeds, you can do that here. You see here that it's using audio speed .speed changer, fairly new thing that we've really never used. And it's really cool that you can do that in CircuitPython. All the sample rates are out here. We're trying to keep things, not too high, but not too low. So at 2250 seem to be pretty good. And we're using WAV files just so that we can, it's easier to play back multiple WAV files than MP3s because we're not having to do all that extra overhead of like decoding MP3. Yeah. And then here's where you can change the volume. So by default, it's 0.4 and 0.5. I think the channel 1 is actually the
music.
The actual, no, not the music. Channel 0 is the background music. And then channel 1 is like the sound effects and the voice call outs commands. Here's how we're handling the non-blocking scrolling. It's important to do that. That is non-blocking so that you can have multiple things running at once. Here's all the states and stuff. Here's the loop. Here's the gameplay and the winning and losing stuff. So all pretty good. If you're trying to reference a good game mechanic, check it out. It's all there and it's in CircuitPython, so it's really easy to manipulate and change up some values. Let's head on over to the wiring. All of the wires are, all the wire lengths are really important because it's you don't want too short or too long wires, especially where it's a tight fit. So everything's there written out for folks. I actually built a second one because I'm actually going to gift it to somebody special. My nephew. He's not watching, I hope, but his birthday's coming up, so I made one for him. So I was able to reference my own Learn Guide, and that's really nice to know that you can follow the Learn Guide, and there wasn't any hiccups. So I was like, okay, this is good. So all the order of operations are pretty spot on. So you'll start off with the slide switch, solder it up to the feather, and then you're going to work on this Holofix sensor. Take your time with this one because it's a little weird to do this. I really recommend these helping hands. I think they're from OmniFlex or something like that. These are tremendous. I have like 4 of them. Indispensable. These are the best little guys ever. I was able to hold this. So this is what it looks like when you're done soldering. But if I were to take a picture of it before soldering, you can't see it because like there's 3 of, there's one holding the sensor, there's one holding the resistor and the wires. So the idea is you want to get the legs, of course, you want to trim them up so that they're about this size. You want to get the resistor. So the resistor polarity doesn't matter, but as long as the legs are bent so that they line up just with these 2 outer legs. So this one, the red wire is, of course, VCC, which is voltage. The middle wire is blue, which is ground. And then the signal wire is the one on the right. And you want to have your resistor go across the voltage and the signal line. So what I was able to do, you can't see the depth here, but what I was able to do is bend the middle one down so that it's not in the way of this resistor body here. So that's my tip there, and that's written out as well in the Learn Guide. Let's go back. You could always click on the image in our Learn Guides and make them bigger. I would recommend doing a right click, new tab, and then see it. So here's what it looks like when you solder it up to the bottom pads of the servo pins. I know it says servo, but you can still use that servo pin as a digital or an analog pin. And then, yeah, that works out pretty well because you can run out of ground pins pretty quick. But yeah, that's my tip there. Otherwise, what's that?
I said I have a trick for the way that I split up my ground on something that doesn't have additional ground pads.
Yeah.
2350.
Yeah. But also we're going to, speaking of grounds, you can do up to 3 grounds on the screw block terminal, which is great. But I didn't have to do that on this one.
Propmaker, yes, for the Propmaker. That one has plenty of grounds.
It definitely has plenty of grounds. So that's good. That's always good. And then soldering up the wires to the NeoPixel stick. They're really nice chunky pads, so you can just solder straight to them. Just make sure it's going to the DN. And I like using these the ribbon silicone cables because they're already bundled together. And then one of them has this demarking, which I tend to do for the voltage. So you can see that little white dash line is the voltage.
I am waiting with bated breath on. I remember Lamar said she was sourcing some rainbow ribbon silicone wires.
Yeah, the day that happens, I'm going to buy them all up.
Oh my God, yes.
But yeah, you can see here, I'm also using, and everything. I definitely recommend these helping the hands because they have the silicone tips and they're really springy and they can open up really wide. And
while still being soft, where it's not like completely crimping your wires.
Exactly. Especially with those PVC wires, they'll get that nice, nasty tight. But these are really nice.
As it's near them, they start melting away.
Right. And because it's silicone, they're heat resistant, so you're not going to burn the tips, which is nice. All right. The next one is like you're going to have to do this like 3 things where you're planning out how to share grounds across these 3 components, which is the toggle switch, the slide switch, sorry, the slider, the slide potentiometer, and the key switch. So we have 3 different wire lengths for the ground, but they're all there, which is nice. We'll get those mounted into the top plate because that acts as a kind of way to kind of get them. It just makes it easier to solder it, and just be careful not to, burn the plastic. But there's plenty of clearance, I think, for folks, so that's good. So I start off with mounting the toggle switch, and then we're mounting the slider, and then of course the chalk switch. It's just press fits into there because it has built-in like little nubbins that make it snap fit. So there you go. That's what it looks like. Just make sure that the orientation is correct. You can see the 1, 2, and the 3 pins on the bottom of the slider. And then solder up your thing. So you're going to go from the toggle switch to pin 3 on the slider, and then onto whatever pin you want, because the polarity doesn't matter on the MX switch. And then you have one long one that's going to go into the feather screw block terminal. And then for the signal wires from those 3 controls, I'm using different colors here. If you're following along, we're going to go with white, green, yellow, and red, because red is for the voltage. So pin 1 is the voltage, yellow is the wiper, and we already did ground, so that's all set. You can see here I annotated with this green circle to tell you where you're soldering. So then you're doing the toggle switch. You either do the far left or the far right. In this case, it's the far top or the bottom, because you're using the middle pin for the ground. And then the last thing here for the signal is the last remaining pin on that key switch. Love me some heat shrink tubing because it makes the wiring nice and neat like it is here. And then we're going to solder those wires, some of those wires, to the feather. So here you can see the green one. That's the signal from the key switch. It's going to D5. You have the voltage pin from the slider going to 3.3 volt pin. And then the wiper goes to A0, which is the analog pin on the feather, because it is an analog component. And then we can start doing some screw block terminal stuff. So the toggle switch is that white wire, so that just goes into that button labeled screw block terminal pin there. So you just want to tighten that up. And then we're pretty much set there with those controls. Moving on, we're going to do the ground from the shared components and the ground from the NeoPixel stick, and that gets secured there. So it's nice that that's isolated there, because you want to be careful of that. And then we're going to do the Neo pin, which is going from the data in from the NeoPixel stick, and the 5 volts, because that's the special 5 volt pin for the NeoPixel. And that just gets secured there. So that's nice. Our latest batch of mini oval speakers have a shorter cable. And with that, you're going to have to extend it using one of our Pico Blade Molex cable extensions. So you're going to cut it down to this length here. And that way it can go into the screw block terminal where the speakers go. So that plus and minus there is actually for the speaker, the audio out from the feather. All right, so this is what it looks like with all your kind of components. You got like this kind of, I don't know, what would you call it? An octopus with all these tentacles coming out. But you can clearly see you got the speaker, NeoPixel, Hall effect sensor, the slide switch, and then those 3 components that are panel mounted to the front panel. It's a good checkpoint. We're pretty much done with the wiring. Now we move on to the assembly. So this is the back cover for the alphanumeric display. That's actually secured with machine screws, which makes it really secure, so it's not going to fall out. And then you can see these tabs here. You see these little tabs here. This is where you're going to connect the LED display backpack PCB. So you do want to connect the cable first, right? And then you can snake that through the little cutout, because it's really tight there. You can see that there's barely any room between the little spot that holds the speaker and the back cover for that display. So that's why I have a cutout there strategically placed, so you can route and snake your STEM QT cable through there. Once that snakes through, then you're going to insert it at an angle, and you're going to see that it actually clips perfectly. So you're just going to want to press fit that. You can always like kind of bend the slightly flex it, you know, because it's a thin part. You can always flex it out, and there's just enough clearance there to like really snugly fit the PCB under that little nubbin. So that's how I was able to secure it without any like what do you call it, wiggle room. There's no like wiggle room for that. It's like really nice and tight. All right, once that is in place, we're going to install the feather. So for the feather, you're going to want these short 4 millimeter long M25 screws. because it's really, really tight in there. So you want the kind of the shorter screws, and those just get secured like that. And then the slide switch just gets press fitted into that little holder there. It's a good snug fit, so you don't have to worry about it falling out, because the edges here, the walls will keep it, but also this back wall here, where if you can see my my cursor, there's when you push up, it won't fall out because this kind of prevents it from popping inside. Let's see. The battery has a nice, you want to connect the battery first, just because once you put the battery in, it gets a little bit harder to have access to the JST port on the Feather. But otherwise, you connect that up, and then you just kind of either slide it through the little battery retainer clip, or just clip it from the top, which works fine. And because it's like, thin enough, it can flex, so it won't break, which is nice. So that so that goes in there without any glue. Okay, what are we doing next? Next, we're securing the NeoPixel stick to the case. There's 2 standoffs that goes right below the alphanumeric display. So you're going to use these M2 screws, because the screw holes on the NeoPixel stick are actually smaller. They're M2 sized, so you're able to get those in there without having to, what is it called? Tap the screws. You don't have to tap the PCB holes. They're just sized good for an M2 screw. So that's good. Get those in there. Just follow the orientation correctly. It's getting tighter and tighter as we continue. So now that we have the NeoPixel stick installed, we can just connect that floating Stemma QT cable from the LED display onto the Stemma QT port on the Feather. So you just plug that in. Speaker, I recommend either using use some mounting tack. I always like mounting tack, because then it'll prevent it from rattling. There's just enough clearance to create a little bit of rattling, so I use some mounting tack. Or you can use the sticker, however you prefer. I like to use mounting tack because I have a bunch of it. But otherwise, it fits in that little housing with enough clearance and wiggle room for mounting tack or tape or whatever. But I always run into these, like, if I make it too tight, then I could break. I've done that. I could break the body of the speaker. So that's why I opted to just make it a little bit looser. It's fine.
Yeah, the top will rip off.
So exactly. Careful. Yeah. So you want to be careful with that. Exactly.
Yeah.
All right. For the wheel parts, you're going to need all this stuff here. Those a 1 M3 screw, your neodymium magnets, and the 3D printed parts. We'll start with sticking the magnets to the outside of the ball bearing. And then this is where you actually need a little bit of demo code to make sure that the magnets are in the right polarity. So the way the Hall effect sensor works is it only can detect the south pole of the magnet. And if you're using these neodymium magnets, it's kind of hard to know what's the north and what's the south pole. So this little bit of code, you can easily upload that to the Feather, and all the code is doing is it's saying, hey, turn on the power for the for the pins. Here's the NeoPixel. We're actually going to use the NeoPixel to let us know that that the magnet is facing the correct orientation. It's going to turn red whenever it detects that the Hall effect sensor detects a magnet. In this case, it's saying if a value is true, or if the Hall effects is true, enabled, then make the pixels red. Otherwise, make it black, which is off. So that's how I was able to test the polarity of the magnets. And you're going to want to do that for all the 4 magnets. And you want to kind of evenly space them out like this, like I have, because that's actually how the wheel has the cutouts for those 4 magnets. Now, originally I designed it with 1 magnet, and that was like not enough magnets to fully like detect the spin, because the thing is that if you just have 1 magnet and the game is a rapid fire trigger, you need to have more magnets. So I ended up adding 4 magnets so that no matter how fast you spin it, it's always going to detect the magnet. So that was like a learning thing there, and a lot of trial and error with this one. But once you get it, once you get those polarities all figured out, you can press fit it into this wheel that has these weird cutout, but it's in the right shape. It's going to be a nice snug fit. So you just want to press that in there. And, the ball bearing is kind of symmetric, so it doesn't matter if it's facing this way or the other way, but your magnets are going to be, facing the right direction. Okay, now we're going to put the ball bearing into the little retainer, and then we're going to insert the little bore piece so that gets sandwiched in between these two parts here. And then a screw goes inside of that little bore that kind of keeps the two parts together. And now you'll see here, this is where the Hall effect sensor gets hidden. There's a little cutout, a little box with a little rectangular cutout. And there's just enough room for it to fit in without interfacing with the wheel. So that's how that's working. So just make sure that the Hall effect sensor is facing towards the wheel, and you'll know it's right because you can just about make there's little, what do you call it, markings? Yeah, there's little markings on the Hall effect sensor, and that's how you know it's oriented correctly, because the markings will show up there. It also has like a shape, so you'll see that. All right, then we're going to put the assembled wheel into the back part of the case with this little registration peg. So that just snap fits in there. And then we can work on assembling the 3-part LED display. So we have a frame, we have our gel, and then we have the faceplate, which is in this case, it's like a black color. So you put in the faceplate, you'll see that the rounded corners on the top are actually a little bit more rounded than the bottom. So that's a good way to kind of orient yourself. So the idea is you put the faceplate in, and then there's a little ledge that will prevent it from pushing all the way in. So it stops there. And then you can just put your cut gel filter over that inside the frame. So then we're going to bring the frame close to the LED display, and then we're going to snap fit it. You can see me, I haven't snap fitted it yet. So all you got to do is just pinch that with a firm grip, and then it snap fits shut. Case check, meaning you want to make sure that all your cables and everything is still good. Everything's kind of connected and secured. And then we're going to add the handle. This is what the design looked like before it went all funky. So this is like the standard, the kind of simple version. So there's a little bit of difference there, but all it is that there's like a little swiggle in the handle. But this is how I originally designed it. So that has little notches on the bottom. So just make sure that these these two notches just line up with it, and they press fit in like that. All right, we're ready to close the case. So make sure your wires are right over the feather. There should be enough room for them to fit over the feather, but not over the battery because it's really tight. So just make sure your wires are over the feather and not the battery. And then you can bring those two together. This top cover will also register with the little cutout on the wheel assembly. So just make sure that that is able to fit. And then you'll see there's also matching notches for the handle. So that's good. Now these don't snap fit, so you're going to need these screws. The only weird screw is this really long screw. So it's a 20 millimeter long M3 screw. And that's because it has to pass through a couple different parts. It has to pass through the back, and then it passes through those two wheel assembly covers, and then it mates with the front cover. So it has to actually pass through quite a few parts. So that's why it's a long screw. But then these can be shorter screws to attach the two halves of the enclosure together. So once that's assembled, now we can put on our little additional thing. So we have a little circular key cap for our Cherry compatible MX key switch. So that just snap fits there. There's two little prongs. So just make those up and do a nice firm fit. And then the slider knob, same thing. That's just kind of orient the little notch with the nub, and then just press fit it in there. And that's pretty much it. And there you go. That's our assembled Propmaker game. And then this just shows you how to turn it on, how to start the game in the gameplay. Yeah. We tend to do this usage page just so there's no like mystery on how to use it. So that's pretty much it. I think it takes folks maybe a weekend to build from start to finish. As long as you have all your parts ordered, it's a pretty straightforward build. Yeah, a little bit of soldering, of course, but I think for intermediate folks, it's really fun.
I got a quick question from Rolls on the metal inserts for the screws.
Yep, this one I didn't use any metal inserts because once you assemble it, you kind of don't need to disassemble it, especially since the battery is rechargeable, and I don't foresee any of the parts breaking over time because they're pretty robust parts. Like a toggle switch isn't going to break anytime soon. Same thing with the slider. Same thing with the Cherry MX button. And also, I kind of ran out of space, so you always need to make your standoffs a little bit thicker, and it just adds more kind of.
The
adds
layer
more
lines act as a thread for
Yeah,
them.
exactly. Yeah,
A lot of the
and
times.
you're not like, see, you'll want. Let me do this. You're not going to be putting a lot of you're not pulling these apart. So if your project has something where you are putting strain on them, then you'll want to use heat inserts. But this is always going to be together, so I don't foresee these parts like pulling apart. So that's why I didn't use any inserts. Now I'll use inserts when I need to, but in this case, we're not doing that. I used inserts on a prop, which was the key blade, because we're swinging it around a bunch and the two halves. So that's where I used heat set inserts. But this one just didn't need it. Yeah. So hopefully that answers your question.
Yeah, I don't think I've had to use it on any of mine.
Yeah, right. I'm trying to think.
The layer lines create the threads for you.
Right. And the whole thing is like you're not putting any strain against these two halves. Like you're actually holding them together always. So it's fun to think about.
Yeah.
Yeah. But if you wanted to, of course, you could add.
I think they would fit, right? Maybe.
Maybe. I just didn't want to like add that extra,
especially for us when we're prototyping and changing things around. Yeah. I feel like we're for us anyway, when we're ideating, we're gonna waste that part because oh no, we figured out we need to adjust
so many of these. Exactly. I printed so many of these. So imagine me having to keep doing the heated inserts like over and over again.
And then it's a waste of time to try to rip them out of the part.
Oh no, never want to rip them out because they are melted in place, right?
Yeah.
Yeah. But that's
so that's our line of thinking.
Yeah.
Where we have to
create
20. We're adjusting things to get the feel right. Or in my case, just let me reprint it again because I didn't like the way that the color layout was for each little block.
Yep. Even on the second build, I ran into that terrible thing where you get just a slight bit of contamination.
Yes, I got that
there. Yeah.
I'm like, oh no, this one little piece of filament flew in and baked into the bottom layer. I'm like, no.
Yeah. Luckily, once you turn it on, that goes away.
Oh.
Yeah. Now you'll always see it though, that tiny little flake.
Yeah, I hate when that happens.
I know. But
if you have time, you have plenty of time. You're like, oh well, let me just print it again, and then you're doing a 4-color print. It's like, oh, there goes 6 hours or 4 hours or whatever.
Yeah, this one takes 1.5 hours to 2 hours because it's switching between 3 filaments. But if you do the single color version, it'll print in less than an hour, and then you just print this diffuser separately, and then you just pop it into the window before you close these two together. So that's how that would work. But yeah, good stuff. Cool.
That is.
I think I took up most of the show with that because it's definitely a build, but a couple days, weekend, you could definitely build it. So that is Prop It. If you want to pick up anything to build Prop It or your own prop or your own reimagined 90s inspired game gadget, use our coupon code PROPIT and get 10% off your order. You can save on taxes with that. So that's good. The sales tax. Cool. Feather. RP2040 Propmaker. Very good. I think we have just enough time for your prototype, and then we'll do the time lapse, and then we can run through the community makes.
All right.
Woo!
Jumping right into what are we prototyping? Back with the Minecraft themed compass. shot all the heroes, doing the assembly for the guide, and the video should be out next week. And here's what we've got so far. Not much has changed that we showed from last week. Got all the waypoints working. Have the little save here, so you can go around and save all the GPS coordinates. Super cool. You have a list of pre-existing ones there, so you don't have to type anything in, and it will save as a JSON file, so you can pinpoint all of your awesome locations at a camp or when you're out on the go. Super cool. Never done a menu-based
right, yeah,
like GPS compass before. You have a ton of options on here, so you have not just your regular compass, but you can have like your marine mode, which will always point to the north.
Okay.
So it's sensing the magnetic field. So you go around, it'll sense all that. Then you have a bunch of options like you can rotate your screen, you can change your theme color, units, your magnetic declination. So you can do those fine offsets with the magnetic declination. And then you have a full calibration mode that happens all on the device. It'll walk you through step by step, doing like the tilts and the figure eights, and it'll save right to the device, so you don't have to go on your computer at all to input any of those numbers. It will grab all that data, the gyroscope and the GPS data, and save it to the device. So that's super cool. I've always wanted to be able to do a self-calibrating project where you don't have to go off, go back onto your computer to input all that data and numbers. It can do it all for you on there. So that was super cool. All of the graphics on here are generated except the needle. It's doing the roto zoom, so it's super smooth. It has easing when you're rotating around, and it tells you all of the info down here, the footer and the header. You switch between the different modes. Of course, the satellites are going to pick up indoor since we are using the outdoor GPS. But you also have the ability to navigate through all those. You have a nice little scrollable menu. You have it arm and fire type of menu. So you click on it to highlight it, and then you click again to actually go to that spot. I'll tell you there, no fix. We have the max insert number of the chip and to do the fuel gauge. So when you plug it in, it'll tell you how much time you have for the charge.
Very good.
Oh, do we have time to actually open this up and take a look on the inside?
I'd save it for next week. We have about 10-12 minutes left.
Cool. All right, so yeah, super full-featured GPS. So we have a couple on Learn, and all of them are, except for I think yours, where it's really like the travel one.
Right, yeah.
I think it's always funny to have a GPS project that doesn't go outside. So this one is actually themed around summer camp. So we've been doing a lot of camping and hiking, and this was super cool to have the kids doing navigating around, dropping waypoints around the campsite, and being able to navigate back to those. So a actual outdoor GPS project that is nice, Minecraft themed, especially with the announcement of that new the sequel coming up. That it was perfect for that. The case is 3-color. You have like took inspiration from the way that the compass is designed, and then we have the flight switch on the back, and then the charge USB for that, and a stemma button up here to switch between the modes, and then the save. So it has multiple functions. You can save the waypoints, and then also hold down to change between your light and dark themes. Definitely going to be using the white version outside because the sun will just block it out.
Oh, right.
And some other things we haven't used in projects before, like a anti-glare film that's usually used on like mobile devices like an iPad or iPhone. Absolutely needed for this project. Otherwise, the reflections won't let you see anything. So you can kind of see here that is overlaid on top to get those glares out of the view. And yeah, super stoked with the way this came out. Took like 4 days just getting all of the UI down, another 4 days getting all of the UX, the user experience, like the way that you navigate through the menus, the way that the buttons work, and then field testing it.
Right.
The different outdoor field tests, like going out, making sure that all of the calibration worked and that all the navigation and that the JSON files were being created properly. So you can just drop those into Google Maps and see all of the locations. Super cool to have all that working.
Nice. All right.
Roll fast. Does the compass point to the last bed you slept in, like in Minecraft? Yes, you can drop a waypoint.
Yeah.
And I should actually, well, this is editable. Your screen of your canned locations. So we got like stronghold, the neither, mine, spawn, home, portal, castle, and outpost camp. So you can definitely add a bed option in there.
Nice. Yes.
Save those. Navigate to those. It's just a JSON file text. You can edit the name when you go back to the waypoint menu. Go in there and look through all of those, and that is so cool to have all the options in a menu system like that. And then even a little help menu too, which is another thing that I thought is cool. We have a touch screen. Why not have all of the options on there to allow you to reference what a lot of the menu system does? So what the button does, how to set up your declination, even a reference of what your declination is based on where your location is.
Yeah.
So have all of that and all referenced, so you can add more to the menu. We're using the RP2350, so we have a lot of memory. We have the dual core. Is it the M33 cores on there? So you can definitely add more functions to it. We have that overhead that allows us to do a lot of the menu and have memory to be able to go in there and have all of those options. So super satisfied with the way that this came out.
Yeah. Can you change the units for our metric?
Yeah. Yep. I just thought that was always funny to be able to have the option to switch between that. And inside of kilometers, it'll also show you obviously meters if you're further away from your.
Oh, okay.
So nice. Those. Yeah.
Cool. Yep. We'll cover all of it next week. We'll have it ready for folks.
I was gonna say it is sandwiched in there. Yeah. Like everything is like on. Yeah. Actually, I got all the parts right here too. If we look at those, it is a frame that is sitting on top with everything mounted all on one plate. And then the battery mount even has mounts for the battery monitor itself as well. Nice. And all that just plops inside. You have all of your multicolor on here, even on the inside to prevent the brightness from the display or the light leaking.
Oh, right. That's
to
good.
Not go through there. So cool techniques for that. And then the way that the lid is actually pushing the whole frame into place.
Yeah, so no rattling around.
Yeah, so there's no rattling around. Even things where the frame itself has like a slot for the stemma button to go inside in, so it doesn't go up and down or rattle around. So
that's good.
That's a cool mounting techniques. Yeah, where the it's part of the lipo holder as well, and then these parts too are also holding a lipo in place so it doesn't slide out. There's like a ton of cool geometrical engineering that went into it as well.
Very nice.
As well as the UX and the UI and the menu and the button functions. And it was so much. I had so much fun working on this, being able to go outdoors. And we didn't do this just by ourselves. We were out there with the kids and all their friends and seeing their expressions like, oh my god,
that's great.
So
that's so great.
Made me feel good, like, oh cool, sweet, I accomplished what I wanted to.
Those are the best projects. The
kids seeing this and going, oh crap, I had one of the kids didn't want to give it up. They like, navigating around with it.
Yeah.
Like, oh, dude, I'm like shooting footage for the video. Come on.
You got to build another one.
Yes.
Very cool. All right. If folks want to pick up any parts to build that, whether they want the RO Feather RP2350 or the 3.5 TFT Feather Wing, you can get 10% off with our coupon code PROPIT. And stay tuned for next week when it's published and folks can have at it. Check it out. All right. Let's quickly run through this week's time lapse. There you go. Pedro, you clicked on it. Very good. This is a fun one. Great for the summertime here. If you're you got access to a pool or a river or something, this is a super cool little marine animal. Or the bathtub. Very good. Yeah. So is it all PLA or is it some TPU stuff?
This is all PLA. The way that it's printed, the weight, when you push it down into the body of water, it just wants to float back up, and then the way that the fins are designed onto it, it pushes it forward. It's so freaking cool.
It's super cool.
I was so impressed.
Yeah, when I first saw that, I was like, wait, what? How's that working?
Right?
Yeah.
I didn't believe it would work.
It's just fluid dynamics.
Yeah, the way that the weight is designed into it. I even have a lower infill than what the 3MF had.
Oh, okay.
And you can adjust the fins as well to adjust the way that it. Oh, there's my camera. Sorry, I'm in full screen. I can't see anything.
I can switch it. Let me see. Yep.
Wait, no, that's Ndesk.
Yep. Is it this one? Like that?
Yeah.
Oh, like this. Why did it change? There we go. And I'll flip it.
Maybe I never added it.
Flip it. Oh, maybe.
Here it is.
All right, cool. Yeah, so it's fairly big, but
it prints all in different parts. So it's the main body, then the sides are all separate, and the fins are all separate as well. So it's not that big. It's just gets assembled. There's actually 3 printed screws that hold it together. So cool.
Interesting.
Dual extruded, of course, but they do have a non-dual color version. I'm using the glow in the dark here, so we can use this at night as well.
Oh, cool.
Should have got some night shots too. But yeah, super fun summertime themed print.
Yeah. Here's the profile. It's a free download. Comes in those different patterns, it looks like. There's like a different pattern of the fins and the body. It's by, let's see, Armengo13 on makerworld.com. It says gliding manta ray, just drop and go. Got a little YouTube video on it.
Much fun.
Seems to be like a nice assembly here. Custom screws that are 3D printed. And you can adjust the wings.
Yes.
And that controls the direction and speed, which is interesting. No supports required. You have a multicolor version and a single color version. And here are some folks printing their own versions, different colors. The glow in the dark one is there.
Yeah. Fun.
Oh, is this like, here's how much poop you'll get? The purge.
Yeah.
Yeah, that's a cool one too. I like that.
Let's see how the H2.
Yeah,
you'll get poop.
That's funny. So
not too much. Though.
Not too much, yeah. Cool. Fun toy. Great for the summer.
Yep. Just little.
Those are pretty.
Yeah, the blue is gonna blend into any body of water. So
right, that's why you see the black one here.
Yeah, do the black or the red. I think yellow.
Really far. Look at that. It's like it goes far.
Yeah.
That's a great pull tool. I'm surprised I haven't seen one like that because we always see like the little
sinkies,
sinkies, but this is like a nice glidey. So that's super cool. All right, check that out if folks want. It's a free download. Great print. Good one this week.
Yeah, we had a shop top. We'll save that for next week. Just use the Fusion's AI to totally design simple design. That is very useful for production here. So we'll talk about my experience using it's the tech preview that they have right now for it. It did a good job. I am impressed.
That's good.
Super simple, but still, it was able to make it parametric and added it as a tool, so I can just drop it in anytime.
That's awesome. Yep, and then we'll save community make. So it's only 2 this week. We'll save those for next week as well.
Yes,
and then I'm gonna either start a new project or I'm going to investigate using KeyCAD to generate some of the Eagle CAD PCBs and turn those into 3D models, because we'll talk more about that. But yeah, that's my plan. Yeah. All right, folks, don't forget 10% off your order with coupon code PROPIT. Definitely check that out. Take advantage of the coupon code. It expires tomorrow, so you have the rest of the day at the time of this recording. All right. Let's see. We'll run down through the shows real quick. Mondays are CircuitPython weekly meetings on Discord. Those happen at 2 p.m. on Monday. Tuesday is 2 shows on Tuesday, starting off with Tim doing his deep dives at 11 a.m. Eastern Time. And then at 4 p.m. Eastern Time is JP's product pick of the week. On Wednesdays, you got us and Show and Tell at 7:30 p.m. Eastern Time. Scott's out this week, so Tim will be taking his slot for this Friday at 5 p.m. Eastern Time. Tim will be doing a live stream. And then Thursday, sorry, I jumped the gun here. Thursday, JP's workshop at 4 p.m. Eastern Time. All right, folks, thank you so much for joining us today and this week. We hope everyone has a good rest of the week. We'll be back next week. But until then, remember to make a great day. Bye, everybody.